So today we'll be learning how to form differential equations by eliminating arbitrary constants. In this case, the arbitrary constants here are A, B, and C. So let's do that now. First of all, we need to find differentiate with respect to x and y. So partially. So when we differentiate with respect to x, what happens is that A becomes the x remains, because when you differentiate with respect to x becomes 1. So the constant remains plus cy, because y is going to be 0. There is no x there. So when we differentiate partially with respect to y, this is also going to be b plus cx, because y is also going to be differentiated. It's going to give us a constant. Now we can also differentiate again with whether with the x, the y, differentiate now with respect to y, or differentiate y this with respect to x. It's going to get the same answer. When we differentiate a, there's no y there, so it's going to be 0. And when we differentiate cy, y is going to go, that's 1, and c. So these are answers. So what we just need to do is just to make, from this point here, let's make a subject of formula. If we make a subject formula, it's going to give us this delta z minus cy equals to a, and for b, it's going to give us delta z over y minus cx is b. So we can substitute into this. So z is going to become what? What is it? A is what? There is z dx minus cy or by x. Sorry, our c is what? Second derivative of with respect to dx dy. Yes, cy. Yes, or bracket x plus, what is our b? Our b is also yes, dz minus y. C is also dx dy x. Yes, then all in bracket y plus c. What's our c? Our c is second derivative with respect to x and y partially. Then our x times y. Yeah. So when we open this brackets, this is what we're going to get: x dz dx minus xy d square z over the x, the y. Yes, also plus multiply. This is going to give us y dz dx dy minus xy d square z dx dy plus xy d square z delta x delta y. Now we can see that some of them are the same. In this case, this cancels out this. Yes. So what do we have left? Is there anything that we can add together? This is in delta x, this is in delta y, delta xy, no. So we can just write our final answer. So our final answer is going to be what? X dz dx rather, plus y dz dy minus xy d square z over dx dy. So that's the answer for that. So let's take another question. So when we have z equals to ax plus by plus a square plus b square. So the same thing we did earlier was going well. When we differentiate with respect to x, a remains, y is going to be away because there's no x there, x term there, so it's going to go. So when we differentiate partially with respect to y, b is going to remain, so the rests are gone. So that means this is pretty straightforward. Just substitute what is x. A is the x, the z, x, right? Plus b is what? The z, the y, y plus a square is going to be this all squared, dx dz square plus for b square is going to be dz dy all squared. So that means our final answer can be just be written in this form: x dz dx plus y dz dy plus dz dx all squared plus dz dy all squared. So that's it about that part. Then the third question, let's take this one. We have z equals to what? Ax plus y. So what we have is going to be, so if we differentiate with respect to x, what we're going to get is a, and if we differentiate with respect to y, all we're going to get is 1. So we can just substitute this into this. So we have what? A is dz dx times x plus, since this is 1, this means 1y, so we can just write as dz dy dot 1. So our final answer is going to be x dz dx plus yes, this is with y, yeah, this is going to be dz dy y. So this is our final answer for this. So that's all we have. Don't forget to like and